Imagine hiring a robot to clean your garage, only to find its hands are snobbier than a glassware collector. Plastic is fine, but old brick? That's a meltdown waiting to happen. A gecko, meanwhile, could probably babysit your dishes and walk away without even breaking a mug. So, why are our best robot grippers basically just fancy spatulas? Today, we're looking at a study that asked a big question. Can we make a robot gripper that sticks to almost anything? No questions asked? And the answer turns out to be yes, if you're willing to borrow a gecko's footwear. Here's the traditional issue with robot hands. They're stiff, unbending, and just not great at meeting surfaces on their terms. Try making one pick up a craggy rock, and it's like shaking hands with a snowplow. Awkward, barely any contact, no grip. So, these researchers took inspiration from geckos and made a super flexible adhesive pad with features just 100 nanometers across. It squishes, it conforms. It's basically the world's smallest, softest beanbag, but for robot fingers. This shape-matching pad spreads itself out, hugging bumps and dents so it can find more places to hang on. Friction takes care of the rest, helping the robot pick up weird stuff it's never seen before, as long as it isn't covered in olive oil. The results? Up to 10 times more stickiness compared to plain old robot pads, even on scuffed, unpredictable surfaces. Why does this matter? Because out in the wild, robots have to deal with a lot more than flat, clean glass. A universal gripper means robots could be useful just about anywhere, from warehouses to orchards to cleaning up your most regrettable DIY project. The detail worth slowing down on is the bottleneck. This idea is instantly visual, but the paper matters because the researchers are not just showing a cool object. They are asking whether the weakest part of the system can be redesigned. That is usually where the real science is hiding, not in the shiny final demo, but in the annoying constraint that kept breaking the design before. A useful way to read universal Bioinspired adhesives for arbitrary unknown surfaces toward dexterous robotic manipulation is to separate the headline from the mechanism. The headline is what makes you click. The mechanism is what decides whether the idea survives after the first 10 seconds. The quick version is simple. How gecko pads grip mystery surfaces. Here, the more important question is, what did the researchers change? And why would that change make the system more reliable? When your boss says, grab whatever you can, and you take it way too literally. Do you think robots will ever have the grip to do our chores? Or should we just keep asking geckos to help out? Let us know what you'd trust a universal robot gripper to grab in your life.